Hi everyone, I hope you are doing well. So in this video, we are going to discuss LeetCode problem of the day, and today's problem is leaf similar trees, and it is an easy level problem. So now they have defined what is a leaf value sequence. So basically you are going to perform a simple DFS or a traversal when you visit the left child first and then the right child. So if you do it this way, you will always visit this particular leaf 6 first, and then you will visit 7 and then 4 and then 9 and then 8, right? So what you have to do, you have to visit the left child first and then the right child, and when you eventually get to the leaf, you're going to push back into your leaf value sequence, right? So in this particular case, you're going to get 6, 7, 4, 9, 8, right? And now you have been given two different routes. So the first route will be of this one and the second route will be of this one. Now you have to tell whether these two trees have the same leaf value sequence or not, right? This is our whole task. So let me just take this particular thing as an example. The problem is very simple. You just have to see how we can implement it. There will be many ways to implement this particular problem, but let us see how we are going to do it. So now we can see what are we going to do. We are going to divide this problem into two different parts. So the first part will be the push part, where we're just going to push some values, and the second part is going to be the pop part, where we're going to pop the values. So let us see. Let's say we have a queue like data structure or a DQ, anything you can take. So let us say we have taken a QUE. In my implementation in my code, I have taken a DQ, but it is not very essential. You can take a Q as well, and the Q will serve our purpose, right? So what are we going to do? We are going to perform a simple traversal in the first tree and push all the elements in the queue. So first of all, we will encounter this particular 6 and then 7 and then 4 and then 9 and then 8. So how is a traversal going to look like? Whenever we are at any node, we are going to visit the left child and the right child, then again the left child and then the right child. And then since this node has no left child and right child, we know that this is the leaf node since none of the nodes are present. So that is when we are going to push back this particular node into our queue. So let's say after the traversal, we have all of these values 6, 7, 4, 9 and 8. So these are the values inside our queue. Now what we are going to do, we are going to perform the pop operations. We are going to perform the pop operations from our queue while traversing through the second tree. We are going to do the exact same thing. When we visit any node, we visit the left child and then the right child, and then again we visit this node, we visit the left child and then the right child. As soon as we reach a node which has no left child as well as no right child, what we are going to do, we are going to consider this particular node as a leaf. Now, since we are performing the popping operations, we have to take care of a couple of things. The first thing is that the queue should not be empty, right? Since we have reached a leaf node here, that means we were also expecting a leaf node at the same condition in the other subtree. So if I have to include a condition if queue is not empty, right? And we have to make sure that the front element in the queue dot front is equals to the my node value, the current node's value, right? So in this particular case, we can just pop the element. If either of these condition is false, I know that my answer is going to be 0, because I have reached this particular 6 here and I was also expecting a 6 at a similar position. But if either the queue is empty or the front element is not equals to this one, that means that the leaves are not the same in both of the trees. So at this particular moment, I can mark my answer 0, but if both of the conditions are satisfied, then I can just pop the element from my queue. At the end, what will happen? At the end, if my answer remains true, if the condition doesn't violate anywhere, if my answer remains true and my queue is empty, you see, this is very important to check whether the queue is empty or not. Let me just tell you the case. Why is it important to check? So let's say we had 6 here, then 7, then 4, then 9 and 8. We also have 6, 7, 4 and 9. But let's say this 1 was not here, this 8 was not here, sorry. So this 8 was not here. So what will happen in this particular case is, at the end our answer will be true because all the prefixes have matched, but my queue will still have the element 8. So I want the queue to be completely clear. I want each and every element to match with its corresponding pair in both of the trees. So this condition is not acceptable and I want the queue to be empty. So at the end, I will return true only if answer is equals to 1, if answer and the queue is empty and queue not empty, right? So this is all you had to do in this particular problem. In one traversal, for the first tree, you're just going to push the elements. In another traversal, for the second tree, you're just going to pop the elements. So now let us have a look at the code. What I've done is I've created a D queue, but it is not essential. You could have also created a simple queue. It is going to work exactly the same. I've initialized my answer with 1 or true. Now what I do, I have this traverse function. It receives two parameters, that is the current node as well as a boolean variable push. So it is going to tell me whether I want to push or pop in this particular traversal. So you see, for when I'm calling root 1, I'm passing 1, and when I'm calling root 2, I'm passing 0. That means this is, in this operation I'm going to push the elements, and in the second operation I'm going to pop the elements. So whenever I come to this particular traversal traverse function, I am going to check if my node is null pointer. I'm just going to return from here, and if my left is null pointer as well as right is null pointer, that means I have reached a leaf node. If push is true, that means I want to push the value. That in that particular case, I'm just directly going to push it. Now if leaves is empty, if I come to this else part, that means I wanted to pop the values. In this particular case, if the leaves is empty or node value is not equal to leaves dot front, I am just going to set my answer as 0. Otherwise, I am just going to pop the element anyways. Now what I am going to do is, so you can also do it like this. You should also add, although this particular code worked, but I believe you should also add this particular check here, right? Because before popping the element, you must make sure that the leaves is not, that the queue is not empty or the D queue is not empty, right? Although I got it accepted, but it is always better to have this particular check, right? Now after this particular part has been completed, you can just call the traverse function on the left and the right half respectively, keeping the push value as it is, right? Not changing the push value. Now at the end, you can just return your answer and leaves dot empty. That means these two conditions should be satisfied together. Now let me quickly submit this and show you that this particular code works. You see, it passes all the test cases and the solution is absolutely correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.